rate of change ones.
Okay, fine. So what exactly do you mean by rate of change?
So basically they like give you a position graph and they want you to like graph the velocity of it.
They give you a what graph? Sorry, they give you a.
They give you a position graph and looking at that, they want you to like graph the velocity of it.
Okay. So velocity is the rate at which the distance is changing. What is velocity? Velocity, in very crude words, if you say, is speed. What is speed? Speed is distance by time. Okay, actually velocity has direction. I mean, there is a little bit of difference between velocity and speed, but for understanding, you can look at it. So
Yeah.
velocity is nothing but speed. Speed is your distance by time. Okay. So we're talking about how much you have traveled in terms of distance divided by how much time you've taken. That will give you your speed or velocity. Velocity
Mm-hmm.
is a vector quantity, which means it has both magnitude and direction, whereas speed is only magnitude. I think that concept you understand.
Yeah.
So here, when they're talking about giving you a position graph and wanting you to draw the velocity graph, you need to see where the position, I mean, at what rate it is changing. Depending on that, your velocity graph will come. Velocity is going to be, say, example here of the kind that Adi, what is, here they have given you the velocity graph and they want you to give the position function. Right? So, all right, okay, fine. So, this tells you. So, now if you see, if you look at the first one, this is your, the position graph is, you are, you can look at the y-axis as your displacement and x-axis is your time. So, if you see, you are at whatever time, whatever, like let's say this is one, whatever your time is, and let's say, irrespective of what the time is, your displacement is always. What does that mean? It means that you are stationary. Your position is fixed. The position is fixed at 2. Okay. When your time
Yeah.
is moving, position is not moving. If position is not moving, that means you're standing in the same place. So velocity is 0. So how long is velocity 0? As long as you're standing in the same place, velocity is 0. Right, Samira?
Sorry, you're like cutting out.
Oh. Have I been cutting out from the beginning?
No, it just started.
Okay. Um, let me try. I'll just repeat and see if it gets better. What I was saying is, if your displacement or S is nothing but your displacement, if your displacement is a constant, it means that you are standing in the same place. You're not moving about. Okay. If you are standing in
Yeah.
the same place, what is your velocity going to be? Your velocity is the rate at which your displacement is changing. But if your displacement is not changing at all, velocity is going to be zero.
Yeah. Okay.
That is the reason why you've drawn the velocity at the bottom over here. So wherever your position vector is going to be a horizontal line, velocity is going to be zero.
Okay.
Okay. Now, if you look at the next graph, again, position is a horizontal line, which means position is not changing. Position is always, let's say if this is 1 along the y-axis, my position is 1 irrespective of what the time is. At time t is equal to 1 second also, I'm at a distance of 1 unit. At time t is equal to 2 seconds also, I'm a distance of 1 unit. At time t is equal to 3 seconds also, I'm at a distance of 1 unit, which means I'm not moving. Okay. If I'm
Yeah.
not moving, what is my velocity going to be?
It'll be 0.
That is the reason why you have a zero weight. Is that clear?
Yeah.
Next, okay. Now, if you look at this, if my position is going to increase, at what rate is my position increasing? If the slope of this line, let's say the slope of this line is 1. What does it mean? It means that for every 1 unit that my displacement increases, time also increases. That's what it means if my slope is 1. Are you able to follow what I'm saying, Samira?
Yeah.
If you have any doubt, please interrupt. If you feel you're not
Okay. Yeah.
understand the way I'm explaining, we can modify and put it in some other way.
Yeah.
Let's say your displacement is increased by 1 and your time also changes by 1. And what is the rate at which your displacement is changing? Rate at which your displacement is changing is going to be change in displacement over change in time. Which is nothing but 1. This is my velocity.
Okay.
And if
Yeah.
you see, this rate at which the displacement is changing is constant throughout the line, is constant throughout your position graph. The rate at which displacement is changing with respect to time is a constant throughout the graph. Therefore, velocity is going to be one straight line. One straight line passing through which point? Passing through the slope of the line, whatever. In this case, if I'm taking my slope as 1, then the line is going to be like y is equal to 1.
Okay.
Okay. Here
Yeah.
also, again, whatever the slope of this line is, I will have a horizontal line right across at that same, whatever the slope of the line is, at that point, like if the slope is 2, then I will have a horizontal line at y is equal to 2. That is going to be my velocity. So what we're trying to say
Good.
is velocity is rate at which the displacement is not a straight line, change in displacement.
Okay.
So rate at which displacement is changing is 0. Therefore, velocity. Or a slanting line. I mean, when I said straight line here, I meant horizontal line.
Mm-hmm.
For any other straight line, a slanting line, normal, any of the lines, the slope is a constant. In other words, the rate at which displacement is changing with respect to time is a constant.
Okay.
Okay.
Yeah.
Therefore, velocity is the constant. When I say velocity is the constant, it will be a straight line, a horizontal.
Okay.
Are you following, Samira?
Yeah.
Okay. Same goes with this also. Now, if you see the slope of this line is lower than the slope of this line. The sixth one has a higher slope. Fifth one has a lower slope. That's the reason why your velocity line is lower here and higher here.
Mm-hmm.
Are you able to follow so far?
Yeah.
Any doubts on this?
No.